Good morning, good morning. How are you doing this morning? It is a wonderful Wednesday. Very glad that you're here with me today. So what we're going to be doing is we're going to be doing a fun project. This is the last time we'll be doing this one. This one is our holiday series. And we're going to be doing a digital snowflakes. We'll learn a little bit more about using our Python turtle to draw. But we'll be drawing some snowflakes, which is kind of really cool. So we're going to be talking about loops and all kinds of stuff. So very glad that you're here with me today, and it's part of our, holiday December series. So before we start out, let me introduce myself a little bit. My name is Alex Cooper. I teach the computer classes for the Columbia County Library in Evans, Georgia, the Harlem Library, and also the Uchi Creek, now Grovetown Library, because we have our new building and everything. Yay. And the biggest question I usually ask is, how can I help? Okay. What questions do you have? How can I help? Especially about, especially about Python coding or anything. So, and if I don't know the answer, we'll find it out. We can learn it together. How about that? All right. So, welcome to class. And of course, any questions. All right, so let's talk about some of the upcoming classes that we have going on. Believe it or not, we only have three. After this class, we only have three classes for the rest of the year. Oh, I know. And then we'll be going into a new year. All right, doesn't that sound good? Happy New Year and all that kind of good stuff coming up. All right, so we'll talk about all the classes that we've had. So this month we've had classes like Raspberry Pi, Google School, some of the holiday classes, and today and tomorrow we're going to be finishing up our holiday themes classes for our STEM and everything. So of course this morning we're doing our holiday coding with Python, digital snowflakes and everything. And this afternoon at 2:30 I'll be on Facebook Live with Columbia County Library in Evans. And the thing I'll be doing there is gadget help, trying to answer any questions you have about tech stuff that you're having any kind of issues with. If I don't get a lot of questions on that, I'll actually go into a lot of the free stuff that we can get with our library card, and also free audiobooks and free ebooks as well. And then tomorrow morning we'll be doing our snowman digital. Let's make a 3D snowman with Blender. And then we'll be finishing up with our third holiday class, Holiday 3D Blender, and animate a snowflake. This month we only had 3 weeks of classes, so doesn't seem as many classes as we usually have, which is fine because it is December and everything. And then we'll be taking a break until next year. Now, I know next year I'm already planning on a few classes that'll be very important. A lot of folks will be getting a lot of new digital stuff. We'll probably go back through our photography series because new people get, cameras for Christmas and stuff. And also cord cutting will be on a lot of folks' minds in January as well. Okay, so let's talk about a little bit about how to get free ebooks and audiobooks. This is just for your information. Our library did switch on October 1st. So if you do have your library card, all you have to do is download the Libby app. When it asks you what your library is, just say Greater Clarksville Regional Library System, and then click Georgia Download Destination, and just enter your library card, and you can download your free ebooks and audiobooks. On a side note, our libraries are open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call into the library with questions. Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. If we can get 100 subscribers to our YouTube channel, then we can actually get our own unique YouTube address. Or just search YouTube for GCHRL videos and it'll pop right up. Okay, so let's go ahead, and I'll come back for a second. I'm back. So let's go ahead, and what we're going to do is I'm going to go ahead and post our project into our chat there so you can follow along with me. And basically this is what our project will be today, is doing our Python snowflakes. Okay. Now, I usually use the MU software, the MU software, but today I'm actually going to be using, following along with the handout, and I'm actually going to be using the Trinket software that's with that. Mainly it's a visual, because one of the things when I'm dealing with the two screens and I tell it to run the software, then it wants to pop up in one screen the other. But it's just a lot easier just to follow their tutorial with the Trinket because it'll all be in the same screen. Okay. So let me zoom in a little bit here, see if I can make our text a little larger. There we go. And with anything, I encourage you basically to have me on a separate device. And then basically have our program, what we're going with, kind of flipping back and forth from our tutorial to, our handout here. All right, so this is basically from the Raspberry Pi website, and we're going to make use our what they call Python Turtle. So create a beautiful landscape of snowflakes using Python Turtle. This is a great fun and great way. It used great in sentence twice. This is a great fun and a great way to start learning how to code with Python. What we will make, digital snowflake out of code like this right here. What you will learn. By making snowflakes with code, you will learn how to draw lines and make turns with Python Turtle, change the pen color randomly, use loops to repeat some instructions and create shapes, use more loops to create spiral patterns, create a function to draw a snowflake. And it has a lot of digital resources on there too. All right, so I'm going to disappear so I'm not blocking anything. Okay, so let's go right ahead. Let's talk about what we will need. All you really need is just a web browser to be able to go to our Trinket website. Okay. Or you can have Python 3 or use the MU software, MU software. So let's go ahead and get started. So how to draw Python Turtle. Okay. Big one is we need to open the blank Python template. Okay. Oh shoot, hang on. I actually need to open that in a separate window. So I'm going to right click there and say open in a new tab. And this is the address to open up a blank one. I'm putting that into our chat. And if we scroll down here, we can actually see our Trinket. Okay. And I'm going to zoom in on our text there. There we go. Should look a little bit bigger. I don't know if I can do it a little more than that. Okay, I think that'll be good. I have had it where it kind of resets, so just realize that I may have to do that a few times. But I want to try to make it as large so that y'all can see it. You know, maybe you're having it on a small device, the video or whatever. Okay, so let's keep going. Now, anytime you see a hashtag with our code, see the hashtag, that just means that the computer reads that, or that's just for us to read. Okay, so the line hashtag just tells the computer that we're using Python 3, the latest version of Python. To begin using Turtle in Python, we need to import Turtle library. At the top of the text editor window, type in import Turtle. Okay, now I'm actually going to just copy paste most of our code by doing the right click. Okay, time to give your turtle a name. You can use a variable, okay, to do this. So you can name the turtle anything with the variable. I'm naming my turtle Elsa. I guess that's in honor of Frozen, isn't it? But you can name yours whatever you like. Okay, so it's going to be called Elsa equals the turtle. Now, a big thing is to make sure that is a capital T there. Okay, so I'm going to select copy. So Elsa space equals space turtle dot capital T for turtle, open parentheses, close parentheses. All right, so now it knows to draw. It knows Elsa is our turtle. We got to let it go. And basically, we're going to have our turtle go forward 100 steps. Okay. So Elsa. Now, if you can't go down to the next line, just like in Word, we have to hit the Enter or Return key. Now, basically, it's imported the turtle from the library. We've named the turtle Elsa, so now we don't have to say turtle anymore. We can just say Elsa, okay? And now Elsa is going to go forward 100 spaces, okay? Now, click Run to run your first turtle program. What happens? So let's hit Run up here. Oop, there you go. And we can hit Run again. So basically, Elsa goes to the right because that's their starting position and goes 100 steps. Now, we're going to actually need to tell Elsa to turn. We don't need Trinket Account to save your projects. If you don't have a Trinket account, click the down arrow and then click Link. Okay? This will give a link that you can save and come back later. Just remember that you'll need to do this every time to make changes to your code, as the link will change. So it's talking about if I go there, click up here where it says, where it says share. If I choose one that says link, it's going to give me this. So this means this is a link to my project. I can copy paste this. I can put this on, a message board in some way. Put it in the chat to show that you've actually completed this. If you have a Trinket account, you can remix to save your own copy of the Trinket. How to turn your Python turtle. Okay. Your turtle is only moving in one direction so far. This is good news if you want to draw a straight line. But to draw a shape such as a square, your turtle is going to have to turn. Okay. Below the line Elsa forward, open parentheses 100, close parentheses. In your Python code, add Elsa right 90. Okay. Again, we have to hit the Enter or Return key. So it's Elsa dot right, open parentheses, close parentheses. Open parentheses 90, close parentheses. So what does the 90 mean? So we know that forward is 100 steps forward. We actually want Elsa to turn, meaning the arrow, turn and point to the right at a 90-degree angle. Okay? Note, turtle uses angles in degrees. There are 360 degrees in a circle. How many degrees does the right angle of a square have? That's right. It's 90 degrees. The value 90 inside the bracket is Elsa dot right, open parentheses, 90, close parentheses, is in degrees. So this line is telling your turtle to turn right by 90 degrees. Add another instruction below to move your turtle forward by 100. Okay. Is this the same code? Yes, it is. Save and run your code to see what happens. You are on your way to creating a square. What do you need to add to your code in order to complete the square? So if I go down here and I paste elsa.forward, open parentheses, 100, close parentheses, it should draw a line, and then the turtle arrow should turn to the right by 90 degrees and then go down. Oh, there you go. Okay, so how do we get it to do a full square? Well, we need her to turn to the right again, so I'm basically just going to copy and paste it below. So it turns to the right 90 degrees, goes forward 90 degrees. All right, and then do it one more time. Elsa to the right 90 degrees, Elsa forward 90 degrees. And then that should be our square, okay? Did you get it? Well, all right. Okay, now, how can we make changes, okay? Well, we can make some simple changes here because we're about to completely change our code, but we want to learn a little bit here. So could we make it, let's say 150 at the start? Well, there you go. But not a very good rectangle, is it? I'd have to make changes to all of these to make them 150 to make it a really big square, wouldn't I? Now, if I go to the 1, let's see, so 1, okay, 2, and then 3. So the third forward, if I change that to 150, there's our rectangle, okay? So we did a square, we changed it, and then made it into a rectangle. Now, if we didn't want to make it to the right, which way could we make it? Well, we could make it to the left. So let's change where it says right to left, see what happens. Well, there you go. It went zigzag that way, didn't it? All right, so we need to change this to the left as well. All right, and we need to make change this right to a left. And there's your rectangle, okay? So basically what do we learn? We can change the steps forward, okay? Now, if we do change the degrees, realize it will not be a complete square or a rectangle anymore. So if I change it to, like, let's say 75, this will happen. Which is what we're going to delve into in just a second. So let's go ahead and let's go back. So we got our hint here. So we did try adding the following code and running the program, which was what we did. What was the result? How can you finish the shape? So we did that. Using loops to create shapes. To create a square, you have repeated some lines of code. This is not the most efficient way to do this. Instead of typing out many lines of code, it is easier to loop. Instead of code to create a square like this, we can change it to make it a loop 4 times like this. Okay, so what do we need to delete? We basically need to delete all of this, and we're going to put in the 4I in range, open parentheses 4, close parentheses, colon. Okay, now big thing is that This needs to be indented, okay? If we don't, then it won't work. Let's go in, let's do run. There you go right there. So less code when you're going to make something do it more than once, okay? All right, creating our spiral pattern. Enough squares. Let's create some different shapes and repeat them to make a snowflake-like spiral, okay? Replace the code for your square with the following. And let's lock through it. For I in range, O parentheses 2, meaning it wants it to do this code twice, the colon. Make sure it's indented, okay? And my copy paste may have indented it too much. I think that only needs to, yep, it sure did. So I actually need to get that to only one indent. For I in range, open parentheses, 2, close parentheses, else forward 100, okay, to the right 60, forward 100, and then to the right 120, which is double 160. We have a new shape, don't we? So what is our new shape called? This will draw a shape called a parallelogram. You can see what it looks like by saving and running your code. You can put loops inside of other loops. This is good news for us, as we can do this to easily make a drawing that looks like a snowflake. Above the line for I in range, open parentheses 2, close parentheses, colon, for your parallelogram, type in I for I in range 10, okay? So how many times will this loop go round? Move your cursor to the below your sequence of code and press the space bar 4 times to indent the code you're about to write. Indentation in Python is very important to ensure that your code works as you'd expect it. Now let's type Elsa write 36, okay? So basically here's our end all right here. We're going to have it similar to what we have now, full range 2, but we're going to change that to 10. Well, hang on. We're going to add a 10 above it, yeah. So we're going to hit enter. We're going to add a 10 above it. Now the important thing is that this needs to be indented. So we need to hit tab on the keyboard or 1, 2, 3. Well, hang on. I think I only have to hit 2 on our trinket. I think so. Let's see. 4 times. I think 2 indents it. So let's make sure our indentation is just like this. So under this, the other 4, this needs to be indented. With trinket, I guess you only have to do it 2 spaces, or the tab will do it as well. Now, let's read our code. So it starts off, I'm going to go to our regular code here. So it starts off here as we want something to happen 10 times. So the first to begin with, our 2 is what? This is our parallelogram, okay? This is our, so we could actually add a hashtag okay? We can add a hashtag for notes. So that's how we make our parallelogram, okay? And we actually want it to loop 10 times up here. So if we run it the way it is right now, do you think it's going to make a snowflake? Actually, no, it won't, because we actually have not told the turtle to move anywhere, or Elsa to move anyplace else. So it's just going to keep writing over itself 10 times. So how do we get it to make it look like this? Well, at the end of our code, we're actually going to have it to all of a sudden, we're going to make it Elsa turn to the right. Let me get her to stop. Hit enter. Paste Elsa. And it's important to make sure that that is indented under the main one here. Okay. So the idea is this not going to run this twice. It's only going to do this part twice. And then when it finishes that, then it'll do this once. And then it'll go back up here. So it's going to do boom, boom, and then restart. Boom, boom, restart. All right, so let me see, what would you call that? How about snowflake turn? All right, let's try it. Save and run your code, see what happens. I think it's working. I haven't zoomed in too much. Let's see. This one I feel like it should have some kind of music. Something like that. All right, there we go. It's perfect. Okay, a perfect snowflake. All right, let's change in the pen and color randomly. And yes, just because it's spelled different, do realize that's the UK way of spelling color, but our code actually uses the US way of spelling color. Okay, now if you wanted to, you could make some changes here, but let's keep on going. We're going to play around with it a lot in just a minute. So let's talk about our color change. Okay, changing the pen color randomly. So far, the turtle has been drawing black lines on a white background. Now it's time to add color. To see the color of the turtle, move your cursor below where you name your turtle and before loops, and type the following. Okay, cray. So we have to do it. Here's Elsa's name. Put a return in there, and then paste Elsa dot color, O parentheses, quote mark, cray, quote mark, close parentheses. Note the color is different in other countries. In the US, it is spelled color, C-O-L-O-R, and in Python, it has to be spelled the American way for it to work. Okay. All right, now let's run our code and see if we get a different color. All right. Do-do-do, 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 do-do-do-do. And the last one, there you go. Perfect. All right. I've chosen to use the color cray. Yeah. But you can use any from the list. Okay. Blue, gray, purple. You can also change the color of the background window To set the color of the background, use this instruction below the code you just written. Okay. So turtle, dot, capital S for screen, O parentheses, close parentheses, dot, BG color, meaning background color, open parentheses, quote, blue, close parentheses, quote, close parentheses. So let's try it. There you go. Do do do. Do do do. Do do do. Do 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 do. 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 All right. Now I'll tell you this. Our tutorial here, I feel like, doesn't really do, it's not really, Christmas colors, I guess you could say. So we're going to change that in just a minute. All right, now there's a way that we can actually change them to random. But let's go up here and let's talk about our different color setup here. And there actually is, there it is, the more colors. Now if we click this, hang on, it took me to another website. So if I click this, and I will tell you, there was one other time that we tried this and I chose some of the colors off of here and they didn't work. So I'm not really sure why that was, but one of the things is we did get it to find some colors. There's one called Snow, which is a nice background color. And of course we have our typical green and red and everything, which is more of our Christmas colors. So let's make a change here. Big thing is to know that what does the thing mean, okay? So this is the snowflake color, okay? And this is our background color. And remember, the hashtag means I can write little comments and stuff. All right, so thinking about what we just learned, now we may have to change it back in just a minute because we're going to make some other changes. So let's make our snowflake color, how about red? And then we'll change our background color. Instead of blue, we'll do snow, which would be different. All right, so hit run. There you go. Do do do. Do do do. Do do do. Do 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 do. There we go. All right, now let's talk about making the colors random, okay? And we'll kind of follow their example, then we'll change it, okay? For fun, you can add a random color for your turtle so that every time you run your code, you will get a slightly different snowflake, okay? First, you will need to import random library. Below import turtle, type import random, okay? So right here, import turtle, import random. Next, change the background color from blue to gray. Okay, now we did change it to snow, but let's go ahead and we're going to follow our handout here. So our background color will now be gray. Below that line, create a variable called colors to store a list of colors to select from, like this. So colors or colors. It's colors, I know, I'm just teasing. All right, so below the line that creates the variable, okay, well, hang on, where do I need to put it? Okay, yeah, okay, background color. So right below background color, so they are doing colors. We're going to do it the same way as the handout for right now, but we, of course, could change it later if we want to. Right now it's gray, purple, white, and blue. At the end of the spiral loop below Elsa, write 36, type in Elsa color, random choice colors. Make sure this line is also indented, so that your program knows it's within the loop, okay? So basically what we're learning here, if you don't have it inside the loop, it'll only pick a color once. But if you indent it, then it knows it needs to be in the same loop that does the 10, meaning that every single, if this was a plant, we would say leaf, but I don't know what you'd call that on a snowflake, will be different, okay? So the same indentation as the right Elsa, okay? So let's look at what that does. It's Elsa.color, O parentheses random.choice, okay? So basically it's just calling up that it's supposed to run the random choice, and it's supposed to list back to our variable called colors up here. So it's just like doing a string to go up here to tell it, hey, you need to pick one of these, and then put it back in that area, okay? All right, so let's hit run and see if it worked. Do all right, there we go. Do. So it's randomly choosing the color there. There we go. Makes it look a little 3D, doesn't it? 3D. All right, more colors, which we talked about that. So let's change our colors a little bit here. And really like the basic, more Christmassy colors, the greens. There's like a forest green here. I'm gonna see if the forest green will work, because I told you some of these I've had it where they don't work. Let's see. So one of the things that we have going on, and I'm trying to remember exactly how, that Elsa actually has it. She always starts out with one certain color, okay, which is this right here, okay. But we may want to make it so that that's random as well, okay. See, every time I start her off, it always starts with red, doesn't it? Because that's the red that's here, okay? Now, I don't think, because I think if I hashtag that off, it turns black. Let me make sure there. Yeah, because that's our default, okay? But if I copy, and I put it there, I believe, nope, didn't like it. Okay, because the colors hasn't been told yet. Hold on. If I put that, so that's the same thing. Okay, I think I have to put it somewhere else, but I will get it to work. Let's see, if I put it, I think if I put it there to work. Yeah, there we go. Okay, so if you put it below where it actually identifies what colors is, okay, then it will choose the first one randomly, and then this is to make sure all the rest of the snowflake petals, I don't know what you would call those. The shapes will be different colors. Okay, so it will choose a different color every time. Okay. All right, so let's mess around with our colors here. So because it's referencing this, we can just change this. So why don't we do red, and it says, let's see, forest green, which would be more like our inside Christmas tree, forest green. I have had it where it actually, if it doesn't know where that color, there we go, perfect. All right, so forest green works. All right, if we do run again, perfect. So adding a little bit of randomization to something really makes it feel like it is doing something different every time. All right, now we're about to change our snowflake, okay? So we're actually going to make a branched snowflake. So let's mess around with this one a little bit so we understand our concepts a little bit more here, okay? So the big thing is we've actually discovered here is how many petals it's going to make is 10, okay? And this is how it basically draws a parallelogram, okay? But how many turns, what angle does it turn at? So if you want it to be a closer, let me say, yeah, fewer petals, you'd make it, let's see, so if I wanted fewer petals, then I'd actually tell it to loop less, but then I also would change this to be, if I wanted fewer, I'd be less, I believe. Yeah. But if I wanted more, anyway, so let's just actually change it, and I'm actually going to type 36 there, just as a reminder. Let's change it to 50 and see what happens. So this means that when it draws outward, it now has changed the angle when it starts its next petal. But I haven't changed how many it should make. So if I actually wanted just that one, so we have 1, 2, 3, 4, 5, 6, 7. I would change this. I'll do hashtag 10 as our original. If I want to change this, I could change it to a 7. And then you'll see that we should have that. And there we go. So there's our wider snowflake. Okay. So let's do the opposite. How about we change it to, we did 30, how about 15? We'll see what that's like. More like a spiral, isn't it? All right, so we need a bunch more, don't we? 1, 2, 3, 4, 5, 6, 7. So maybe like 30 or something. We will see if that works. So a sharper angle means that the petals are closer together. Interesting. It's like kind of doubling back on itself. Oh, we didn't quite make it there, did we? Oh, no, it is. There we go. Okay, so now so 30 is too many. Looked like it stopped for me, but I guess that was just drawing over the same thing. But anyway, so that's more like a spiral. Okay, snowflake. So we kind of did our two main choices with this. Okay. Next, we'll actually be making a snowflake that is branched instead. It will look like the branches of a tree, kind of like more of your, atypical snowflake. All right, so let's talk about our next section here. We're going to talk about the pin up, pin down. Okay, pin up, pin down is just like if you were writing something on a piece of paper. You don't start drawing on the edges of the piece of paper. You pick your pen up, put it to where you want it to be. Let's say if you're going to sign your name or something, put it down, draw, sign your name, and then put your pen back up again. It's the same concept, okay? Your parallelogram snowflake is cool, but it does not look as snowflake-like as it could. Let's fix that. For this drawing, we need to move the turtle from center of the window. The pin up and pin down instructions let us do this without drawing a line, just like picking up a real pen from the paper and moving it somewhere else to start writing. Type the following instructions below the colors list. Okay. So where's our colors list? Here's our colors list right here. Oh. We made a change here, so it's actually expecting us to have it the original way. So turtles, background colors. Yeah, okay, so there you go. We're fine. So right underneath the colors list, let's go ahead and let's add a return in there, and then let's paste that in there, okay? Or of course, if you're going to type it too. So Elsa.pinup, open parentheses, close parentheses, Elsa.forward, open parentheses, 90, close parentheses, Elsa.left, open parentheses, 45, close parentheses, Elsa.pin down. So it's actually lining it up. Let's go ahead and run it. This may look a little silly. Yeah. So basically what it did was this is actually a different start position. So it starts here. It's going to move over here and then actually start instead. Okay. All right. So let's write the code to draw one branch of a snowflake and store it inside a function. Then you can simply repeat it over to create a complex snowflake. Define a function called branch, okay? And that needs to be, yeah, just right underneath what we just added. All right, so let's go below that. Add define branch. Remove the code for the parallelogram snowflake loops. Oh, add the following code below that. So basically, we just need to delete all of this. Well, I think it'll actually leave the random. Yeah, so they say to actually do that later. So we're actually going to put a hashtag in front of this one. So put a hashtag before that. And then basically everything else needs to be deleted. Okay. So basically we're just down to this, just like that. All right. Remove the code from the, oh, we just read that. And we'll go walking through what we have. So we have define branch, for space I space n space range, open parentheses 3, close parentheses, colon. We need tab, so because this is below that, it has its own section, okay. For I in range, 3 times, okay. Else a forward 30, else a backwards 30, else a right 45, else a left 90, else a backwards for 30, else a left for 45, and then else a dot right 90 degrees, else a dot forward 90 degrees. Now, this actually is going to be creating our branch, okay? See, there's our branch right there, okay? Remember that indentation is important. Make sure to check that all your indentation is correct, otherwise your code will not work, okay? Now, let's go ahead and let's run what we have. Oh, it doesn't like it. Okay, so we have to finish it first. Write the final section of code to call the branch function, which means to run it 8 times, okay? You can use the loop again as for your last snowflake, okay? Put a hashtag at the beginning of the else a color random instructions to turn into a comment. This means that the computer will skip that line of code. You could delete the line, but you might have to use it to add color to your snowflake later on. Save and run your code, and a snowflake should appear before your eyes. And we're saying for I in range 8, the branch, okay, so there's our branch, else a left 45. Oh, doesn't it like that? Hang on. Oh, does that need to be indented? So it says for I think we did this last time. Yep, needs to be indented. When I copy paste it, sometimes it doesn't indent properly. So what else needs to be indented here? Is else a right? Yep, sure does. Else a right and else a left need to be indented. Now let's see. So there's our nice branch, okay? So basically, see how this is 3? And if we told it, let's mess with it a second so we kind of get our base down here. So if we told it 1, oh, well, that didn't really work, did it? That's funny. Okay, so if we told it, sorry. Okay, so it comes out there. So okay, so it goes forward. Okay, and then it goes backwards, turns to the right, 45, and then it does that 3 times. Okay, and that creates our 3 branches. Okay, so it does that 3 times. If I change this to 1, see, it only created 1 branch. Okay, let's say if I change this to 4, 2, 3, and there's your 4. Okay, so this is a branch. So this creates our branch, All right. Now this creates our angle. So after it runs that, okay, then it turns 90 degrees and then goes forward. So this is our, I guess we'll call it pedal. What should I call that? So it's the next pedal. I guess I'll just call it pedal because we know it's the pedal angle. Okay. All right. So it draws our branches. So this whole section here is our branches. That's our pedal. This part comes in here, so it's actually telling it to make 8 of these branches. Okay. So branch is this. Okay. This whole thing, they're calling one branch. Okay. So there we go. I'll call it 3 branch because that makes a little more sense. I'm sure that has a sub name or something. So there's your 3 branch. It goes off, makes another branch. Okay. So the whole thing here is our branch. Okay. Then we have it where it turns 45 degrees. And then it does our, well, shoot, hang on. So I got that a little confused here, I believe. Yeah, so it goes out, does that. It turns the 90 degrees. It goes forward 90 degrees. And then it starts to pedal again. Let's see. So the turn left, this actually starts that. Yeah, so if I make this a 1, yeah. So this is the control. This is one big branch here, and this is actually controlling our angle. Okay. So it was on 8 before. So if we, this is actually the pedal angle. Okay, so let's see what our snowflake looks like. There you go right there. There's our branch, kind of atypical snowflake right there. All right, now it's going to give us a challenge. Can you uncomment the random color instructions and place it in the function so that each branch has a different color? Okay. So it comes to this part here, and we actually want it to be underneath there. And let's see if that works. Now, because we reset the top there, it should stay black. Do do do. Do do do. Do do do. Do 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 do. Now remember, we always have this issue where it starts with the black right there. So again, I'm going to copy this and right below here, going to have else a color. Okay. Then that means the first line should have its own random. Okay. And then when it gets to the end, it's going to do the random again. There you go. Perfect. Do 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 do. Maybe it should be like jingle bells, dum dum doo 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 doo. All right, now, can you create a snowflake function and then repeat it all over the window to create a snowflake landscape? Okay. Can you draw snowflakes of different colors and sizes? Ooh, and that's a little bit trickier there. All right, so let's talk about making more snowflakes. So basically, we have it here where it changes color. So this is our very important, this is our branch if we want to change our branch. But let's see if we can actually get it to go out and move, and to basically move to a different section, okay? So what we need to do is we need to have our pin up, pin down. And I think that should do pretty well because it will be in a different section. So let me see. So we've got our colors going on, choosing a different color. Let's see. So if we actually had it in this section, do we want it to do it? Go out, it do the pin down, and then we basically want it to start over again. So could we make it do, So if we actually move this up to being equal, that would affect what we get. No, this would be after each branch, so that would look like this. And then it goes and draws someplace else. Yeah, we don't want that. Now that doesn't look right. We want it to, ooh, that's going to be a big one because you have to make the whole thing loop. Then everything has to be indented properly. Let's see. So let's see. So if I make it, okay, that's fine. So I make it go out right and then start over again. And we already kind of messed around with our the pedal part, which we might do that in just a second too. That's kind of fun. But let's see. So if I wanted it to, so I want it to finish. So it finishes here. Okay. And then if I want to do another one, let's see. So I'd have to make it start over. Let's see. So that would make that do that 8 times. Then it moves down to the next section. So is there something called range? Yep. So this is our range right here. So if I wanted to do branch again, random colors, petals to the left, 45 choice. Okay, so I'd have to make my own full range. What was the previous? Just doing a loop. Let's see here. Yeah, for range 2. Okay. It has define on there. Okay. So if I go down here, let's see. So if I add a for range 2, how do I make it go back to the branch then? Right. Okay. So if I do this, let's see if that would that work. So it should do one of the snowflakes, and then I'm telling it to do the pin up, pin down. Let's see. So we have our code making one snowflake. We're trying to get it to move and then make another snowflake. Do-do-do, 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 do-do-do-do. There we go. What happened? Oh. It's off screen, so we can't see it until it comes back into the screen again. Oh no, it didn't work. Okay, so why didn't that work? Okay, so we had it go off the screen. Maybe that was too far. And let's see, turn to the left. Pin down. Make the branch, started doing the branch. No, it did one branch. Okay, so it did a branch, which was this. Okay, and then it got to here, and it didn't do this part. Okay, so so got to do a branch. Left ramp, but needed to do this 8 times to get the actual. So this needs to be sub underneath that one. Sub underneath. Okay, now. Oh, there needs to be below that. All right, now let's see. So it makes snowman. And then basically, I've told it to pick up the pin, move away, do 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 do. Okay, there we go. Do 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 ha 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 do 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 do. Oh, now it's gonna look like a bunch of X's. So if I change the angle a little bit, it won't look like that. It'll look more like a crisscross pattern. Do 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 do. Do 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 do. Kind of a crisscross, but it looks kind of like X's. I don't mind a crisscross. Ah, that's kind of interesting looking. Okay, so let's see. So we have it doing the, here's our branches here. Here's how many we told it to do was 2. And if we actually changed our angle, how about we make it 50 instead? So this is our, I guess you could hashtag this, say, new snowflakes. So that's how many new snowflakes. All right, let's see. So we've changed our angle a little bit. So basically after it creates a snowflake and it comes out to create the second snowflake, it should then do it at a little bit of a different angle. And because if it's off a little bit, it should seem a little bit off when it makes the second one. Yeah, it's a little off. That's great. There you go. That looks more like kind of a pattern, it being on top. Not a bunch of X's for some reason. There you go. I'm interested in where would it go next. Would it keep just spiraling around? Because if I send it back out and it does to the left, it should. So if I tell it to do, let's say 8 instead of 2, original number is 2. Maybe move it a little bit further out instead of forward. 90. What if you made it 110? That may make it look like more like separate. All right, let's go. Do 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 do. Do 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 do. Do 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 do. Do And if you do want smaller snowflakes, then just decrease the forward, on everything. But you need to do it so that it is, less equal everywhere. Maybe they're a little too big for our screen size. All right, let's see how that lines up. So that is 20 steps further over. Okay, so they look a little bit more separate this time. Now it should start kind of doing a circle because I have it going to the left. Okay. Of course, something else you could do is if you move let's see, the color choice to the end, then every new snowflake would be a different color. The whole thing would be a different color. Oh, where'd it go? Did my thing at the end? Nope, it's still out there. That might be too much space. Yep. Okay, so what if we did our angle? Let's see. If we did 35, what would that be like? Okay. That's not as far out. Far out. There we go. Now that's going to spiral a little bit more. So by closing in our angle there, Oh no, where'd it go? Oh, okay. So now maybe it needs a sharper angle because it still seems like it's going way out. Okay, if I give it like a 15 degree, let's see what that would be like. I mean, your only other choice is you could actually make the snowflake smaller. Like I said, you have to go through each section here and decrease the forward or the backward. There was one time we got some really interesting patterns by changing the length of the back the where it says backward on there when it's drawing backwards, because then that was like creating a new snowflake almost. All right, now our angle. Okay. So then our next snowflake should be, let's see, so there it should be about here. And then our next one should be about here. Hopefully they'll all stay on the screen. There we go. Oh, well, I haven't done it yet. Okay. So there's that one. See, it needs some kind of music. Oh, and that's when it looks like it shoots off the screen and starts drawing. That's funny. It's still doing it. It's just way over there now. I have a feeling it would come back though. Hmm. We're trying to kind of focus on making it loop. But if you didn't care about making it loop, you could make it kind of box square, in there. Of course, making it draw, 110 forward. Maybe that's too much. So we originally started with 90. If we made it 75. Okay. I think it's a little bit more of what we were going for. All right, the third one will tell the story. Okay. Mm-hmm. I think every time, because it like does a draw off. If I actually had it, oh, I bet that's what's really happening here. So every time it finishes, it doesn't stop in the middle. Okay? So if we actually got rid of this, because I really don't think this is necessary, because I just wanted to kind of start drawing right where it starts. Okay. Because if we do that, okay. See, when it does that final shoot off there, it's like I need that to stop, where I need it to be in the middle. And then the code would basically tell it to, go this way and then do a pattern and then stop in the middle and then go this way and then do a pattern. That's kind of what I want it to do. So if I got rid of, let's see, is that what I think it is? Turn to the right 90 and go forward 90. So if I turn these off, that should mean that it shouldn't do that line at the end. Let's see. Nope, that's not it. That's funny. So wait, does that need to be? It needs to be over. Okay, so oh, is that there? So I need to stop it from doing that last push out there. So where is the last push that it does? So it's similar to the start here, the 90. So it's a 90, I believe. Let's see, it's a forward. So apparently it's not this. This all deals with creating the branch. This deals with, let's see, so it thinks it goes backwards, turns forwards, turns right, backwards 30, left 90. So if I change that to 70, what would that do? Yeah, so that brings it right back to the center. So this is where we get some funky snowflakes here. And I think last time we did this, it was almost making it look like it was a reef. Okay, so make that 90. And where else does it go forward or backwards that far? Let's see. Forward 30, backwards 30. So we come out, we draw a branch, so that's our 30 here. And then it turns its angle and then shoots off forward 90. So that's what that is. You see where it goes back and then it goes that way. So I got to figure out how to get, if I can stop that, then I can get it to do shorter, because I think that's throwing my angle off. So exactly how does it do that? So it does a branch. Okay. Make sure my code, we don't have it someplace else where it steps forward. Let's see, so it's 3 times. Here's your branch. And then it turns left at 45, and that's where it goes off to here. Okay. That creates our new branch is that. Pin up, pin down, forward. Let's see. Our range. Backwards 30, left 9 degrees, right, backwards. So to the left, to the right, 9 degrees of forward. Let's see, so it always has to get out there and then starts doing this. Okay. So we start with I'm not sure. Okay, that looks great. So there's our cluster of snowflakes. All right, as we're getting close to wrapping up class here, hope you enjoyed doing our little bit of Python turtle in one of our holiday classes that we have here. Doing our snowflakes, making a cluster of snowflakes. We kind of figured out our main section here with our changing the color, getting it to randomly choose the colors that we want, kind of a little bit more of a Christmassy color scheme, I guess you'd say, or, you know, wintry with the green, the red and stuff. Oh, gold should be in there too, maybe. And then we talked about the petals. I'm sure that's not the proper term of that. And we also talked about the branches and all that kind of going down with this new snow. Changed a few things and kind of got more of like kind of like a cluster of the snowflakes now. So it's not shooting off screen anymore. All right, so kind of wrapping up class now. Thank you for joining me today. Hope you enjoyed our class. And we actually finished up with doing our different snowflakes. And we just kind of played around a little bit there at the end, trying to get them to move around, change their shape a little bit. Don't forget about our class this afternoon. We'll be doing a gadget help on Facebook Live, the Columbia County Library Facebook Live page. So come join me for that. If you have any tech questions, now's the time. That would be the time to ask. Happy to help in any way I can. If I don't get many questions, I'll start talking about all the stuff that our library has to offer, or digital stuff. And then tomorrow, come join me. We're going to be doing at 11 o'clock, Let's Make a Snowman, 3D using our Blender software. And then tomorrow afternoon, we'll be doing a holiday 3D Blender, animate a snow scene. So it'll be a car driving down through a snow village with our Blender software. Don't forget that our library is open with limited services and hours. Curbside holds pickup is available. You can go to gchrl.org for details or call the library questions Monday through Friday, 10 a.m. to 5 p.m. Don't forget to like us on Facebook and subscribe to our YouTube channel. Or you can also search for our channel on YouTube by GCHRL Videos. So thank you for joining me today. Have a great afternoon, and I'll see you later this afternoon or some of our other classes. And stay safe. See you later. Bye-bye.